Hey, good morning, students. And today we'll be learning about PyTorch, which will be the main framework for doing deep learning. So in my machine learning class, I will be covering very basic deep learning algorithms through PyTorch, like linear regression, logistic regression, convolutional neural network, recurrent neural network, and maybe some reinforcement learning just to get you excited. But the real deep learning will be, I'm actually preparing something called Python for deep learning in my repository. And that will be the new tutorials on deep learning. But in this tutorial, I will be mainly focused on the very basic PyTorch-ish kind of tutorial, very basic one, to get everyone started on PyTorch and deep learning, right? So great. So today is the first tutorial on PyTorch on deep learning. And we can take a look. We will be working on this data set in which we're going to take the temperature, rainfall, and humidity. So these are X to predict the yield, apples and oranges. So we have 2Y all together, right? And what I have prepared for you is X and Y, which is a bunch of numbers hard-coded. And then I will teach you what are something called data loaders provided by PyTorch. We're going to define some layers and a loss function and gradient descent, and we're going to put them together. To give us a little bit idea, the concept about PyTorch, the philosophy, PyTorch provide a lot of pre-built components that you can put together by yourself, in which you can create any neural network or architecture you want. So that is the beauty of PyTorch. And at the same time, it avoids you to create a lot of boilerplate code, so that you don't need to implement something like the gradient descent or the loss, the Adam loss function, which is a very typical in all neural network, right? So that is really great for those developers who made PyTorch. So anyway, let's get started. So here I have 5 samples here. So my M is 5, and I have 3 features: temperature, rain, and humidity. And I have a 2Y, which is the yield of apples and oranges, right? And here is my X and Y. So we can run this. And we can take a look that X.shape is, okay, so X train. So we have 15 samples and 3 feature each, right? So these are just here in this picture is 5 samples, but in fact I have a lot of samples, like 15 of them. Typically for deep learning, the more data you have, the better. 15 samples won't suffice. So that is the downside of deep learning. That is, it requires a lot of data to start learning some patterns, unlike machine learning, because machine learning, if you learn correctly, you will realize that machine learning has a lot of assumptions behind each of the equation. So because based on that assumption, you use much less data. So that is the good the pros of machine learning. But for deep learning, it requires a lot of data. So that is that. All right. Let's try the Y train. All right. And okay, so this is the big Y because it's a matrix, because I have a 2 yield, right? So I have 15 samples corresponding to this X train, and the target for that is orange yield and apple yield. All right, great. So I think we are good to go here. So we got the data correctly. Firstly, I think I need to import Torch. Okay, anyway, we're gonna import right here. How about right here? So we're gonna say import Torch. Right, so this is it's not called PyTorch, it's called Torch. So you import Torch, and let's give a few minutes, a few seconds. All right. And then I'm just gonna show you which version I'm using on. And you may want to try to see whether you have some CUDA available on your machine. I don't, because I'm using my Mac, so it will say false. But if you're using some GPU like 3060, 3070, 4060, etc., and then I would say device equal to torch.device, and I would just say CPU. Okay. If you're using GPU, you can just say torch.device CUDA 0. If you want to use the first GPU, if you have two GPU in your computers, and you want to use the second one, you just put 1. All right. Okay, great. This one will be necessary when we indicate which GPU or CPU we want to run our PyTorch on. Okay, great. So now we are great to go. So now we got the X and Y, right? So we got this, right? There's one more thing I want to do, and that is converting them into torch format. So I'm gonna say inputs is a torch dot from NumPy xtrain, and targets is equal to torch dot from NumPy ytrain. All right. And so now if we try to check this, we'll know that this is a torch tensor, and similarly for the targets, we know this is a torch tensor. And of course, we can try input shape and target shape, and that is 15.3. So you can see that it's called torch.size. In that case, maybe we can try size. Does it work too? I think it does, but I think we need this. It's a function, yes, and it return basically the shape. All right, so those are that. The only reason why you need to convert it into torch is so that, well, you can use it with the torch framework. Okay, great. So I think we got the X and Y ready. So now I think we can now work on data loaders. So what are data loaders? Do you remember in which you do something like for IDX and random.sample from X, right? And maybe you want some batch size, something like this, right? I think you recall that, right? Which is basically you randomly pick like 50 samples from X and then train, right, in your machine learning, right? Well, we can still do this, but this is a lot of hard coding. So PyTorch guys say that, hey, you don't need to code this. This is something that we can take care of it. You can focus more on your architecture, right? So that is the data loaders for you. So it's like a very nice library. You can just use it, and then it will be great. Before we can use the data loaders, we need to make sure that we convert our X and Y into something called PyTorch datasets. All right. So here we're going to just use something called from torch.utils.data, import tensor dataset, and then we're going to say train dataset is equal to tensor dataset, inputs and targets. All right. So that is the dataset. In PyTorch, what do I mean by dataset? Well, the X and Y will be paired in each of the sample, right? So first of all, wait a minute. Why say it's not defined? It's right here. Give me 1 second. Yep. It's okay. So maybe I can clear output, restart, and run all from the beginning. Maybe you would now know. That's okay. Whatever. Maybe. Okay, maybe my Pylance is not working. Give me 1 second. Okay, now it works. So now maybe we can take a look at what is the train data set, right? How does PyTorch treat the data set? And you will see that okay, what is happening? The output restart run all. Okay, great. So what is happening is that you will now have two tensor, one, and that is the sample itself, which is a 73, 67, 43. So these are the first row of the data right here, right? And then it will always be paired with the samples, which is 56 and 78, right? So that is how PyTorch look at X and Y. It will always pair the X and Y in each of the sample together, right? So that is something good to know. Now what we can do is from torch.utils.data, import data loader. And we're going to say that batch size equal to 3. And the train data loader. So this will be something like an iterator in which we created, and then we can loop this guy accordingly. So we're going to say that data loader, the train data set, and batch size shuffle equal to true. So we're going to shuffle them before, and then num-workers is basically how you recall that when you do the loading data set and training, you can actually do it parallelly, right? So in here, we want to do parallel training, maybe 4 at the same time, right? So that is, everything is supported by PyTorch, by the way. And then maybe I can show you how it works. So we can say for X and Y and train data loader. Now is an iterator, and then I can just print X and Y. And then I'm just going to break this, right? And you can see that for each of the batch, I have 3 samples for X and 3 samples for the Y, right? So that is data loader for you. Really, really handy. But I'm just going to cancel this because once I run it, the data loader will remember the position. So I don't want to run this. I just want to clear out the outputs and restart everything and run all so that my train loader is start from scratch. Okay, great. So the data loaders are done, and also this one is done. So I'm going to close it. Now we want to define some layers. So I just want to explain what is layer, even though it's called layer, which scare people out. It's basically matrix of multiplication. And when it comes to matrix multiplication, it's nothing but just W XW. And I think you're very familiar with this, right? This is basically linear regression we learned in the first class. And basically that's it, right? That is basically layers. But the beauty of deep learning is that you can stack layers after layers, and that creates a lot of power for the deep learning. All right, so let us see what is layers here in PyTorch. So torch.nn, that's nn. So this is referred to the neural network module. And let's say I have some random layer called nn.linear23, right? And so what do I mean by a linear layer of 2-3? So I can try to print some random layer dot weights, right? And you can see that I have a shape that is 2-3, a matrix, which is composed of the weight. And of course, we can print the shape. And we can see that a linear layer of 2-3 is basically a matrix of shape 3-2. All right. The only reason why it's flipped is because the W is always with transpose, right? So that is something you may want to know, right? So that is the weight will always be transposed, but that is that. But anyway, that is the shape of the weight. What else? We can print the biases. And you can see we got 3, right? And this will be according to the number of features we have, right? 3, yep, right. You can imagine X having 3 features. So it will look something like this, right? X at WT, right? So here X will be MN, right? And at W will be just now, I think it's already transposed, right? So the W just now we saw is 3, 2, right? And that is yep. So we have 3 features, right? And 2 is basically the number of Y we will have, right? And that is okay, let's say 2. And then what we will get is M comma 2, right? And in fact, Y will also have M comma 2 because we have for each of the Y, we have 2 answers right here, right? And that is the only reason why we have 2 right here, okay? And of course, when we add the biases, so maybe I can show you the operations a little bit quickly. So maybe I can show you the operations really quickly. So let's say I have inputs. This is my inputs, right? And that's 53. And let's say I have some random layer and then inputs. And of course, I think I did something wrong. Give me 1 second, okay? It should not be that case. Okay, give me, okay, I should have 3 comma 2 here. Okay, great. So now, because my inputs here, this is my n, right? So I need to define that my linear layer should be accepting 3 features, and it will output 2 things, right? So in this case, that's why my linear layer should be that, and then I get the inputs. So now I can actually call this sum out, and we can actually print the shape, right? And you can see 15 too, right? So what this does is nothing but taking the inputs, right? Dot with some random layers dot weight, right? So that is the operation it does. But here you can see that it say that, oh, cannot be applied, but because blah, 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 because it actually do transpose right here, right? And then you will get the numbers same as what I'm doing. So this is exactly when I say inputs some random layer, is just taking the inputs and dot with the weight transpose. All right. And if you forget what is this weight, if you take a look, it's basically 2, 3. So that's why we have to transpose it. All right, great. So hopefully you will not be scared of the layers. The layers is nothing but just some kind of matrix multiplication. All right. Of course, we can also count the number of parameters, right? And the number of parameters is basically the idea of the number. So you can actually count, right? So we have 6 here, and we have 2 here, right? So total 8. So how do I get this number? Well, we can actually number of parameters equal to 0, and we can say for param and some random layer the parameters, and total number of params plus equal to param dot nominal. Nominal is basically just to flatten the whole. So you can see that when you type dot weight, you will have a lot of vector inside each of the. So things club inside vector of matrix. That's number is just stretch everything into one single thing, because we just want to count how many parameters. And so now I think we can count the total number of params, and that is 8. All right, great. So hopefully things are great. So I will just clear all outputs, restart and run out, just to make sure that everything I type is in order. That is the downside of Jupyter Notebook. Is it does not preserve any earlier thing. It's good for education. But anyway, now we can define some loss function. So we can say that the loss function is just MSE loss. Again, if you're confused, what is this? This is basically just say that loss is equal to 1 over m y minus y hat. I think you recall this, right? And then everything here dot sum, right? So if you recall this, we don't need to code this by ourselves. We just call this, and it will work for us. So that is PyTorch. And for example, we can, how do we use this kind of well, we just call this function and just put the targets and the outputs. And outputs. Sorry. I think I don't have, I call this out, right? So and you can see that now I can print the MSE. You just print the MSE, you will get this one. So you can see that there's a huge loss just now. Out is basically what I have just tried here, right? And if you want to get the number, actual number, you just call item, all right? So this is just to demonstrate how do you define a loss function. How do we define the gradient descent algorithm? So if you remember W equal to W minus alpha, this one, we don't need to do this anymore. We just call optimizer equal to torch dot optim dot sgd sgd some random layer dot parameters. So we're gonna say that, hey, these are all the weights I have. Please update them accordingly, and then the learning rate is basically 0.001, and momentum is 0.9. Momentum is basically is basically you still account for the so usually we update the weight based on the current gradient, right? But actually momentum is like, hey, the previous gradient we still want to account it. So we're just gonna say plus 0.9 for the previous gradient and plus 0.81 for the previous second I mean the two previous gradient, right? And etc. So that is the meaning of momentum. It will always multiply with the previous and keep the gradient momentum. So that's why usually when you use momentum, it creates better results. So it's recommended to use them. All right. But first of all, I got some problem that it doesn't detect my some random layer. So all right, so give me 1 second. All right, so now I got my gradient descent algorithm. So let us review what we have been doing. So we specified X and Y. We learn about data loaders. We define some layers. So layers is basically matrix multiplication. There's nothing other than that, right? Of course, later on, we're going to learn something called CNN, but in linear layers, it's nothing but matrix multiplication, loss function, and then the gradient descent. And now we are ready to put them all together as a linear regression, right? So we're going to say num epochs equal to 5. And for those who don't remember what is num epoch, it's basically one epoch equal to one cycle of exhausting all the data for training, right? And plus notice I did not have any validation data sets, whatever. I only have training data set because today is a really basic PyTorch session. But in the future, I will slowly add, and hopefully you'll gain a better understanding on PyTorch. All right, so how do I do? So Walt, we can set up the idea. So we're gonna loop the epochs, and then we're gonna loop we're gonna get the batch, right? And based on the batch, we're gonna do, we're gonna put our batch into our device so that it knows where to train. Then we start the training. So the training is we first predict, right? I think you remember this. And then what do? We calculate the loss. And then what we do is we backpropagate, right? But to do backpropagate, you need to calculate the gradients, right? And then you update. Okay, so here maybe I just gonna call calculate the gradients, and then number 6, what you do is you update the gradient, update the weight. Sorry, yes. So this is a really similar to what you would do in linear regression in your machine learning class, but here I'm just using the PyTorch framework to teach you how you do it in PyTorch instead, right? So that you understand the philosophy about PyTorch, right? And finally, after each batch, maybe we're going to print some of the performance. All right, great. So I think we set up things correctly. We're almost done. So now we just say for epoch and range num epochs. We're going to get the batch. So we're going to say for batch X, batch Y, and train data loader. We're going to put our stuff in our device. We just use a function called to. And when we predict, how do we predict? Well, we're just going to call some random layer that we just define up there. X. How do we calculate the loss? Well, loss is nothing but criterion y hat and the batch y. And you calculate the gradients. To calculate the gradients is super simple. You just first of all make sure that you clear all the gradient in the system first, and then you just do backward. This will calculate all the gradients. So this is an amazing function, right? Just one function. You don't need to code anything from scratch. Just call backward, and it can calculate all the gradients. And to update the weight, you just do optem.step, right? And that's that. And then you can print the summary of the performance. So we're going to say print epoch, and loss. I think I don't need this. Loss is loss dot. Okay, maybe I'm going to put some 2F here just to make sure that is 2 decimal, and then I can run this now. So you can see that in the first epoch, I'm getting a loss of 12,000, and it's slowly decreasing, right? It's still running. Oh, okay. So my loss comes up, but hopefully it will go down. Okay, it's getting down, which is good. Okay, so that is the total of 5 epochs, right? So now I can have any torch array, and I can now use my some random layer. This is already trained, so you can put whatever inputs and targets here, and you can get the answer right away, right? So that is the inference step, right? Anyway, hopefully you learned a good bunch of ideas in the PyTorch first tutorial, and we will go to the logistic regression in the second tutorial. All right, see you. Bye-bye.